Good afternoon, everybody. Welcome to today's University Business web seminar, Camera-Based Parking Guidance, the Evolution of Campus Parking, brought to you through the generous support of Park Assist. Before we get going today, a few housekeeping items. For technical support, use the chat panel at the right of your screen. Select my name, Jason York, and type your message. If you're having any problems hearing at any time during the presentation or can't listen through your computer speakers, we will post a phone number and access code at the right chat window. To submit a question to our panel at any time during the presentation, please use the Q&A panel located below the chat panel at the bottom right of your screen. Send your question to all panelists. Don't see a panel? Click the expand panel triangle in front of any panel name. And do you need access to the presentation at a later time? Everyone who had registered and attended today will receive an email with links to the slides and the archive recording. And with that, I'm going to get our program kicked off today with Jeff Sparrow from Park Assist. Jeff, it's great to have you with us today.
Hello?
Yep, it's all to you now, Jeff. Take it away.
All right. Thank you. All right. So, thank you for the introduction and thank you for joining us today. Our goal today is to provide you with a general overview of parking guidance and, more importantly, camera-based parking guidance technology and how our systems can address the challenges yours and many other college campuses around the North American market are facing today in their parking environment. So who's going to be presenting is myself and Scott. So just a little bit about myself. My name is Jeff Sparrow. I've been in the parking industry for over 25 years, and I started off in the parking operations side of it, where I managed large parking operations, municipal projects, sporting events, Major League Baseball, Major League Football, and then mixed-use projects, and then moved from there into the technology side of it. With the past 4 years, implementing camera-based parking guidance systems for Park Assist. Scott?
Yeah, hey everyone. So I've been with Park Assist for 11 years now, having started out in our service and support department in our business. And sat in a lot of different seats, and now heading up our entire technology side of the business, but focused on the product management end of the things that we build and sell. So a lot of different viewpoints in terms of what the problems are that our customers are facing.
Thank you. Okay, so today what we're going to go through is talk a little bit about Park Assist, the challenges that campus environments are seeing today, the technology trends that are being utilized, and then really discuss more in depth about our technology, the camera-based solutions, and how it can be implemented in a campus environment such as yours. So let's start it off. Park Assist is recognized as the leading parking guidance technology company in the industry. We developed and introduced the first camera-based parking guidance solution. And when we brought this solution to market, we wanted to really change the parking culture. We wanted to make parking guidance a mainstream product while also providing important, real, actionable data to our business users. By doing this introduction of PGS system with business intelligence, we're backed by a company, a group called TKH Group. It's a publicly traded company. It's a $1.8 billion annual company, and this allowed us to infuse more capital into our research and development department and help make parking guidance, specifically camera-based parking guidance system, a mainstream technology. Our technology is patented in the United States, the UK, Australia, and as well as Canada. Our smart sensing system is a multifaceted solution that is designed to really maximize revenue, cut some costs, minimize those costs across the camp environment, while also elevating the customer experience. And our solution is really built around a very rich API-driven ecosystem that's leading the way for different technologies to easily share data between different applications. Our technology offers the ability to elevate the customer experience through our smart infrastructure. What that means is, we're able to provide real-time information to your parkers through their journey, getting them from one point A to point B in a very timely and convenient manner. Sorry about that. We provide real-time actionable data down to the bay and down to the vehicle for use by our business users to really provide a business intelligence that makes your management team be able to drive better business decisions. We're constantly looking at ways to improve our technology, and the technology that we're deploying, so we have our M4 sensor that we're showing today. Our technology is we're forward thinking in how we've created our systems, and we're looking at ways of how this system is going to integrate with future technologies. One of the examples that we hear a lot of is how our system is going to integrate with the autonomous vehicles. And so that's one of the things that Scott and his team is really focused on is meeting those needs for future developments. So since introducing the parking, the camera technology to the industry, we've installed the most camera-based installations worldwide, and we're currently installed in 41 countries, and we're continuing to grow that market. So some of the customers you may be aware of and who may be on this call today, University of Texas, Dallas, University of Monterey, Washington University in St. Louis, Duke University, Auburn, and University of California, San Diego. At the end of this, we're going to go over a use case for the University of Texas, Dallas, and discuss how they implemented our technology in their operation to improve the overall performance of their day-to-day operation. So, over the past, I would say past 4 or 5 months, I've really been focused on trying to understand some of the challenges that campus environments, on college campus environments have today. And so what I came across was, when I spoke with a number of the transportation department heads, security is a very widespread concern and challenge. What some of the, providing a safe and secure environment campus-wide for their students and faculty and visitors is really a key objective in their overall operation. Permit enforcement, as these campuses are starting to grow and add more and more parking real estate, enforcing the permit and parking policy becomes very challenging. And so that was one of the things that they really want to address in the very near future. Time and convenience, reducing campus congestion, getting customers, the students, the faculty to open spaces and getting to their class on time. What's going to be interesting in the next, probably the next few months, and my daughter's getting ready to head to school in 2 weeks, is that after I talked to a number of students, their attendance was not really looking to diminish at all, but what they were looking at is the revenues were going to diminish because more and more people are staying in state. What that could mean is that you're going to be having more and more local students driving to campus, so this could really impact the overall real estate and the availability of parking as it was in previous years. Surface lot parking, that was one of the biggest challenges. How do you really effectively manage and monitor those spaces and show students and find those hard to get spaces, show those effectively to the customer base and make sure those spaces are being utilized. So those are some of the challenges that I heard. I mean, there was a huge panel that I went through and got a good understanding, but these are the ones that I thought were the most common between those campuses. And so what do we look at right now in terms of major technology trends that are going to help deploy and reduce these challenges on an environment? We look at license plate recognition. And so when you look at campus environments, what is the most common access or credential that a student and a faculty may have is their license plate. And so, years ago, license plate cameras and that technology was very expensive, but now with the ability of deploying this type of technology, you can monitor, you can view and see where people are parking, you can enforce this policy. So they're really wanting to implement license plate recognition into their environments. access and revenue control. And this has changed over the years. Years ago, it was a gate, a ticket dispenser, and an access card. That's how people were getting in and out of parking facilities, and that's really changing. And the dynamic is changing to meet the needs of students. So on your environments, what's the most common technology that students are using these days on a day-to-day basis is their phones. And so what we're seeing in terms of major technology is mobile application payment processes. Automating parking policy compliance. You know, we're going to talk about parking guidance here in the next few slides. Putting a parking guidance, a camera-based parking guidance system, using license plate recognition, you're able to really automate your parking policies by monitoring spaces, monitoring who's parking in there. And so, you know, that's a technology that's really up and coming. It's been prevalent probably for the past 3 to 4 years since we've introduced this technology as a mainstream product, and we're seeing it being used in this environment as well. And then surveillance. You know, surveillance is a technology that's been around for a while, but cameras are becoming cheaper. You know, they want to make sure that they can monitor much more campus area. However, the big challenge that they're going to have in a parking structure is, you know, as on a side of a building, they can put a camera and they can monitor a large area. Once you get into a parking structure, how do you really monitor space by space? You're going to have to put those cameras almost over every space. And that's where we're going to talk about our technology and how our technology can trend to reduce the cost of all this infrastructure. So let's talk about parking guidance and how it's evolved over the years, and then we'll get into the camera-based technology. Originally, and actually being still used today, is what we call our zonal system. And if you haven't seen it or have used this technology, what it is basically a wire that's embedded into concrete and connected to some type of technology that counts. So as a vehicle drives through an entry and drives over this wire or this loop, it will count that customer coming into a garage. As they exit or drive over the loop that exits out of the area, it takes that car out of the inventory. And so really, it's a very simplistic system, provides limited information. It really only provides occupancy and a count. The issue that you have, there's two issues with this, is to understand how it's working. If you want to see it working, you actually have to be on site. You have to watch vehicles drive over these areas and see if the counter goes up and down. Additionally, it's very low on its accuracy. You know, consultants, when they put this into a specification, they actually their goal is to get to an 85% accuracy for these types of systems. So what does that mean? If you got a 10,000 space garage or 10,000 space surface lot and you got cars coming in and out, you're going to have an inconsistency of around 15%. That means that you're not utilizing the overall space. Or worst case yet is you have got vehicles driving around looking for space and there's nothing available. So on a day-to-day basis, you need to send somebody out there to actually do manual counts and then have those counts reset. So it's very, very laborious. About 20 years ago, ultrasonic was introduced, and you all may have seen ultrasonic systems in your area. What it is, it's a light that goes over every space. Looks like a Christmas tree in your parking structure. And similar to a zonal system, the light will actually monitor the space. And as a car pulls in, it acknowledges that there's a car there and it'll turn the light red. As the car backs out, it will verify the car's out and then turn the light green. Again, very limited in its capabilities. It provides occupancy. You're going to get a little bit more data. You're going to see like dwell times to understand how long people are parking, but that's really to the extent of the data that you're going to get. Additionally, you're not going to be able to understand how it's performing unless you're on site. So to understand if the sensor is working properly, you have to visually watch a car pull in, see if the sensor turns red, and if a car pulls out, see if the sensor turns green. So while it is more accurate, you know, if you have to do an on-site monitoring system, that means it's going to be very difficult to verify how accurate the system is. And that's where we came into play, and we want to develop something that was more of a truly a technology product that provided more than just parking guidance. So by using cameras and a sensor, we're able to really provide a data-driven system using license plate information as well. So this data, we're able to capture when cars pull in, when cars pull out, and the actual frequency of that license plate. So more data, in addition to having that data, we're also able to stream live video. So when we talk about one of the challenges on a parking campus, is that you want to provide security. Well, now if you put this into play, you're going to get people to their spaces more quickly, and you're able to monitor those spaces in a surveillance aspect. The sensor itself is its own computer system. It has its own brain, and that's an important piece of it when we talk about how the system works, how we can monitor the system, how we can check and verify accuracy. So, for example, if the sensor, someone unplugged the network switch or turned off the server, the information in that sensor continues to store data and continues to display an accurate lighting system for the customers to utilize the parking guidance system. Once that server network switch is plugged back in, that data flows back and you're really not losing any data whatsoever. So that's one of the challenges, but additionally, we're able to monitor the health of the system. So now it's a network device. We can see, is the device offline? How is the system performing? What's the health of the system? We can look to see, is the camera aimed in the right direction? Is the lens clean? What's the accuracy rating? So we can verify accuracy by using the cameras to take snapshots, and that's what we do on a daily basis, multiple times a day. We'll take snapshots of every space and verify that it's accurately verifying vehicles in their spaces or not. We provide those reports on a monthly basis to our customers. So when we say we're 99% accurate, it's truly a verifiable system. Sorry about that. Our sensor, so here's a close-up of it. Our sensor is mounted to a channel. That channel is installed at the ceiling level and down the middle of a drive aisle. When we mount the sensor to that sensor has a camera on each side, and each one of those cameras can monitor up to 2 spaces. So this sensor can essentially monitor up to 4 spaces. The camera itself is a 5-megapixel camera. In addition to taking snapshots of those individual spaces, it's also capable of providing live streaming for a surveillance product. At the bottom of that sensor is a halo light, a 360-degree viewable light. And that LED light is capable of producing up to 16 million different color possibilities. And what we traditionally see is a red, a green, and a blue. So red meaning that all those spaces are occupied, green that there's at least one space available, blue means there's at least one ADA space available. But we're also seeing in some of our operations other products that they also want to make sure that they're readily available and display it through a color mean. So electric vehicle charging, for example, what we're seeing as a standard color is purple. When we talk later on about University of Texas, Dallas, they were able to change the colors to match the permitting of their students and faculty. So the students would actually be able to understand where they're able to park by the color of their permit versus the color of the sensor. So again, very flexible system in terms of how it can function. Here's a quick video that gives you a little bit more perspective of how it works. As you arrive at a facility, we have the wayfinding sign that shows what spaces are available by level. As you get to that level that's available, we have internal directional signs that quickly get you the most available spaces in a timely fashion. Once you get to that aisle, you're then able to see visually the light of the sensor immediately draw to the green space, pull in. If all those spaces that sensor's covering is occupied, it will turn red. Once a vehicle pulls out, the light will actually turn green. Immediately that data is sent to signage, so it's updated on a consistent basis real time. So the basic story of this of a parking guide, and specifically camera-based, is really to elevate the customer experience through providing the parker a seamless journey. And so we're just going to kind of go over that very quickly. what we want to do is we want to offer customers, your customers, the ability to see what's available before they actually leave for their destination. We can do that via a mobile app or a website. So, for example, at a campus environment, the student would get onto their phone, look to see if they had 5 opportunities on the campus to park for that permit. They could look to see what facility is open. They look at all 5 facilities and they say, oh, there's one that's 400 spaces, the other 4 have like 2 or 3 spaces. I'm going to head directly to the one that has the most available spaces so I don't waste my time driving around. Now that I'm on site, we have wayfinding signage that helps direct them to the open spaces in a parking facility. So for example, the image we have here shows that level 2 is full. So as they pull up, they're going to see very quickly that level 1 and level 2 are full. Let's not even waste my time. Let's drive up to level 3 and we'll get to the parking space much quicker. Now that they're on level 3, we have internal signage that directs them to the open spaces. And so we look for the quickest distance to get them to those open spaces. So now that they're driving around, they see what's available, and they pull into the actual aisle. When they look down the aisle, they're going to see the smart sensing LED with the green light and pull in that's where the vacant space is. And our goal is really to reduce the time to park. I've got a slide that we're going to talk about, a study that we did that shows how impactful the parking technology is in improving the time to park in a parking facility using our technology. Once that customer returns from their destination, I do this many times. I go to the airport. I park on level 3 right next to the terminal, but I'm always taking about the same flight out every time I leave. There are times when I leave in the afternoon and those areas are totally full, so I'm parking on a different level in a different area. And when I come back, my brain thinks I'm on level 3 right next to the terminal. I can't remember where I parked. So these kind of tools are what's useful for those types of customers. We can use a mobile payment app, we can use a Park Assist kiosk, or we can integrate with other technologies, allowing the customer to input their license plate or a partial of their license plate into the technology, and then it will show them exactly where their space is and how to get to that space. And then, last, and what we're looking to develop here in the very near future is time to exit. I think when we talk about parking guidance, it's always been about the journey to the destination. However, when you look at a parking operation, many issues happen at the exit. How do I get out of the garage? And so we really want to take the time and the understanding and the research to see how that plays into our parking guidance solution. And so once we deploy this time to exit, our goal is to be able to offer additional, consultation of maybe you need some additional signage to help people find their way to get out of the garage. Okay, so now you got the general understanding of a parking guidance system, a camera-based parking guidance system. We really want to understand how Park Assist and the camera-based solution can really, provide an impact to a college campus environment. So I brought up earlier the reduced time to park, and one of the biggest issues is how do you get students to those open spaces and display that message to them in a timely fashion? Well, by using Park Assist and a parking guidance solution, we're able to show that through research that we've done and an application and a feature that we've implemented into our software. So when we install our system, we keep the lights of the sensor off and the lights of the signage off. However, we're continuing to gather data on people's parking habits, and we use that data to benchmark their parking journey. And so then we flip a switch, we turn the sensor on, we turn the lights of the signage on, and now that we can monitor their activity in a live environment, we can compare the 2 research data. And what we found out is through a Brisbane airport is that by implementing a parking guidance system, we were to decrease the time to park by anywhere from 25 to 60%. And so it's really key to have these types of systems to get people to understand where the available parking is and getting to those open available parking in a quick and timely fashion. Additionally, what we found in the correlation between this is what kind of impact does it have on the carbon footprint? And so we, conducted a number of these types of studies throughout throughout a number of our projects. And we did a study at a Westfield Shopping Center in Los Angeles, a 2,500 space garage. And by understanding the reduction in searching for time of where those available spaces are, it was averaging that over a course of a year, by implementing the system, 44,000 gallons, almost 45,000 gallons were saved on an average year by implementing the system. So again, it does impact the carbon footprint of a university environment. Installing a camera sensing system to increase security is really important. So by installing our system into a garage, it provides a unique vantage point. You know, the system can identify license plate information, can monitor occupancy on every space, but more importantly, now it can capture streaming surveillance of each one of those spaces. So this technology will assist in crime deterrence and provide additional protection against liability. You know, so if you were to actually have to place cameras over every space, it just wouldn't make sense. But now you can actually use one technology to monitor your garage, monitor the usage of your garage, and also view surveillance at a unique vantage point, covering every space and in between those vehicles. You know, streamlining and optimizing operational efficiencies. You know, installing a parking guidance system will allow you to measure what is going on within the parking space. You know, this is critical to optimizing your operation. You know, additionally, understanding how the facility is operating is key to realizing what needs to be changed in order to increase efficiencies. So, you know, when we really look at this, you know, getting the data, understanding where spaces are available is key to any successful operation. More importantly, as we talk about the optimization of parking in a campus environment, I'm here in Arizona. We have 4 universities in the urban environment that are you know, Northern Arizona, ASU, and University of Arizona, and Grand Canyon. When we look at those environments, they're landlocked, and you know, so you want to make sure that you're maximizing your overall spaces and understanding the uses of those spaces before you start to build up. Building a parking structure can cost anywhere from $20,000 to $25,000 per space. So, you know, this data is really important to understand the usage and the overall efficiencies of your parking garages. You know, policy compliance and enforcement, and this is, you know, an area that has always been challenging for college campus environments. You know, currently what happens in an environment, you know, in a college campus is, for the most part, you know, some people have gate systems, some of them do not. But if you don't have gate systems, you know, the enforcement team is you know, enforcement's being conducted basically on a routing method. They're either walking or driving around and trying to verify if people are parked in the right locations. So you may capture one this hour, but you won't be back again in that area for another 4 hours. And so what happens is you got to boost that circling in that time frame. And so you know, what would be beneficial is if you had eyes on every space of your parking operation, you could have the ability to deploy officers based on specific situations. So you could be proactively, you know, deploying your resources, effectively operating your enforcement team with fewer and fewer people. You know, additionally, what you also want to do is look to see, understand the abusers. You know, so if you also have the ability to see who's actually parking, and then maybe you can provide a better enforcement policy and understanding how you can get the message out of where people are supposed to park. You know, lastly is what we see in a gated system is once they close off those gates, and so some people, like, you know, medical centers and faculty centers, they'll maybe want to close off sections of the garage in what we call a nest. And those nests, you know, they'll put maybe 100 spaces set aside for, let's say, doctors, nurses, or other faculty. Those 100 spaces with a gated system, that's basically restricted for any other use. So if you only have 60 people in there at any given time, you're not maximizing the overall use. By using our system and monitoring who parks in there, you can change the dynamic of that space. So you got their license plates, you got their permit number, you can reserve these 60 spaces on Tuesday for faculty, and you know who's parking in there. And so if someone else parks in there, you can enforce that policy, ensure that that's only reserved for the faculty. However, on Wednesday, maybe it's down, the faculty shrinks to 20 spaces. You can now change those spaces by color coding them, for example, and then shrink those spaces down to the 20 spaces allotment and use those other 80 spaces for other people that are parking in the garages. So effectively maximizing your overall use and also making people enforce with the parking policy that's in place. Scott?
Yeah, thanks. Thanks, Jeff. So moving on to INX being our, just move forward there, Jeff. Yep, perfect. INX being our latest development and being our new software cloud platform. So Jeff briefly touched earlier that we've been in the market for a while, and in fact, some 12 years ago, we introduced the first cloud reporting platform to the parking industry. As we've seen this product grow and evolve, we gained a lot of insight into what the parking industry was truly needing, and also we had a sense of where the technology was going. This resulted in INX, which is a ground-up build, a totally new software platform designed to accommodate the shift to an IoT-based device management, along with the handling and processing of our event-based data in real time. The end result being a cloud platform built on today's technology with a lot of the future functions that we have in mind baked in and ready for. So jump to the next slide there, Jeff. So from a UI perspective, our motto during the design and build process was data at a glance, with the intent being that any of our users should be able to read and interpret the data very quickly and easily. It also means that the UI has to be completely customizable to show and prioritize only the metrics and areas that are important to your operation. The same goes for how reports are generated. On top of the standardized reporting functionalities that are pretty much inherent in most systems that are out there today, the ability to build and save and customize and ultimately subscribe to the reports that are specific to your system, to your operation, to your facility, is also a key feature. In addition, using our IoT edge-based sensors and devices, the operator gets full visibility across the state and configuration of all options that are baked into the equipment provided. Jump to the next one, Jeff. So INX as a platform comes with a lot of things that you would expect, a lot of the functionality you would expect from such a cloud app platform, with a few others to come as well. So, the typical sort of dashboarding that nearly all cloud platforms are coming with today is baked into the standardized offering of what INX is, with a lot of customization. Incisive reporting, so being able to go back and interrogate what happened earlier today, yesterday, last week, last month, last year, all of that stuff is there. Viewing your facility from a map perspective, so seeing what's happening where, what devices are where, the state of those devices, how you configure those devices, heat mapping from a reporting perspective, all standardized stuff. Parkitect is our workflow engine, enabling you to build rules within your system, very much like an if then that style approach, to be able to operate your facility as you need. Simple things like, hey, at this time, I want to change the light colors. I want to be able to turn the system off overnight. I want to change the weekend configuration from a weekday configuration because the use cases are different. All of those things are programmatic in the system to be able to get alerts at different points from allowed or not allowed parkers. All that stuff comes in the system. Park Finder is our ability to search using your license plate or other vehicle identifiers. to find vehicles either in the garage now or the history of any of those vehicles that have visited your site. And Park Assistant is the way that our support teams interact with you through this platform, enabling you to raise support tickets, reach out to any of our support staff, all in the one interface, giving you an end-to-end, one-stop location for the interaction with your parking solution. On top of that, we bring further functionality to market over the next few months. We've got a list of other functions. Jeff touched on some of them earlier. The time to park and time to exit is something that's very mature in its development. And this is a key part of getting metrics around what's going on the customer's journey, both into our facilities and out of our facilities. These are some of the key areas, key reasons as to why someone may or may not drive or may not park at your facility. So understanding what's happening is a key part of those pieces. Being able to predict what's going on based on recent history is another key element. Bringing some of the enterprise functions that you require across your facility, like single sign-on, simplified branding, other consultative services are coming across. And being able to detect things beyond just vehicles in the garage are some of the other things we're looking to bring to market in the very near term. Tying these functions back into the core functions of the system, so being able to create alerts based on different objects that are appearing in the garage, being able to put time to park or time to exit messaging on signage, for instance, getting alerts on time to exit messaging, all those things are some of the exciting functions that are coming in the near term for our product set. Thanks, Jeff.
All right. Thanks, Scott. So, like when we started, we wanted to bring up a use case so you could see how one university, University of Texas, Dallas, used our parking guidance solution to really impact their overall parking operation. And so, just a little bit about University of Texas, Dallas. They've been seeing substantial growth, like many college campuses across the North American market. Their capacity doubled from going from 7,000 to 14,000 spaces. They built 3 new garages, and they wanted to implement a parking guidance system in there to monitor those spaces. So their objective was to really, one of the main objectives is to streamline their parking operation, provide a really elevated customer experience for their visitors, for their students, their faculty, and other vendors that were on campus. They wanted to make sure that that when they implemented a permit system, that they had an increased adoption of this permitting system. And as you can see by the sign here, what they had the ability to do was look at how people were parking and change where people parking on a day-to-day basis. So, for example, if you look on level 1, they had meter parking as well as purple permit parking. Levels 2 and 3, they had orange and gold parking, and level 5, they had green parking. And so they wanted to be able to understand how people were using the garage and on a day-to-day basis change the availability of where people were able to park. And so they wanted to understand this through getting real data from a parking guidance system so that they can manage and forecast how their garages were being utilized. So the results were basically that they were able to display through our sensors and color coding of those sensors where spaces were available, which impacted the experience that those customers had and reduced their time to park. Additionally, they were able to show where the space were available through a color coding system, and it increased the value of the permitting system, making it easier for them to enforce their parking policy. And then lastly, as they continued to gather data, they were able to flex and forecast parking needs based off of historical data and trending of that data. So at the end of, whoops, sorry about that. What it was able to do was to be able to add to their goal was really to be a sustainable, parking environment, and it really added to their story. But more importantly, is that they were able to improve their overall parking operation. And some of the things that they wanted to consider when they actually rolled this system out was to be able to use the parking guidance system, have a smart sensing system that could have a broad spectrum of colors. So again, going back to those permits, they had the green, the gold, the yellow, all those different color of permits, and they wanted to be associated with the sensor itself, so people could visually see where they were supposed to park. Our system was able to match those color coding system and define it for those user groups. And so, you know, Chris Aquino from the University of Texas, Dallas, you know, the ability to change parking spotlight colors to match our parking permit need was very important to us. And so, you know, it was a very big success story, and you know, it's a great project for us, and it's a great use case as well. So with that, I am going to send this back over. Get it up there. Hold on. 1 second.
All right, Jeff. Thank you very much for that, and Scott for his insights as well. A lot of great takeaways there. And we're going to now move into the Q&A portion of things. Reminder, if you do have a question for our panelists, use the bottom right Q&A panel to ask it at any time here. So we'll get started here with a question. So this obviously can be for either of you, whoever wants to answer it. What size parking garage is your parking guidance system best for?
Guidance is a perfect solution for any garage that's easy to get lost in. So typically anything above about 500 spaces, depending on the layout, is a good candidate for guidance solution. We've done garages anywhere from about 80 spaces, with our largest being 13,000. So.
And a couple of questions have come in now about surface lots. So Jeff or Scott, can you answer any questions about how the system works for surface lots, or what solutions you have for surface lots?
Yeah, so go ahead.
No,
Scott. Okay.
You got it.
You know, for surface lots, we've got a product called S1, and it's a standard off-your-shelf camera that's mounted to a light pole or to a building or something that's got some height to it, and we're able to capture those images viewing down on multiple spaces. So where you saw our sensors that are used in a garage, we cover up to 4 spaces. In our S1 project or product, it can cover up to, let's say, 50 spaces depending on the height. And so what it does is it monitors the overall occupancy of those spaces, and it can provide surveillance for those. The one feature that's not available from that high up is capturing the license plate information. But it's still able to maximize, provide information to the signage, real-time data, down to the bay about where spaces are available.
Okay, great. And this one is back now focused toward the parking garages. Is it one camera per, the question is it one camera per bay to capture parking activity in each bay?
No, the sensor is installed over a drive aisle, and then each camera can view up to 2 spaces. So even on the view on the surveillance, you're going to capture those images between those 2 spaces. So you're going to capture both those spaces and in between those 2 vehicles. Did that answer your question?
Yeah, no, that does. And this next one came in during Scott when he's talking about INX. How is the licensing done for INX?
So like any cloud service, there's an ongoing cost to a lot of these functionalities. So we have a licensing structure for INX that enables you to bundle it as part of the upfront purchase or pay it as an annual fee. So we can work with either model, but it is delivered by the cloud. It is effectively a subscription, but we do have some different ways of costing that.
And this one is, geared toward either of you, but how can camera-based parking guidance improve traffic flow in my facility?
Scott?
All right, I missed part of the question. What was in relation to traffic?
Yeah. No, sure. How can camera-based parking guidance improve traffic flow in my facility was the question.
So one of the things that we saw in the Time to Park study, part of the offshoot of it was by putting a guidance system in place, you eliminate a lot of the random or blind looking for parking that goes on. So where you have a multi-story garage, for instance, providing information at the entry that this garage is basically full, or this garage has availability on level 4, for instance, enables a lot of that traffic to go directly to those spaces rather than driving aimlessly through the garage. So we definitely saw a reduction in the traffic volumes during some of our Time to Park studies, where we spent a lot of time analysing the behaviour of vehicles in the garage looking for spaces. And some of the research that we're seeing in our Time to Exit is showing a similar result. Eliminating some of the traffic moving into the garage is having the effect of improving the traffic exiting the garage simply by just reducing the traffic overall. We're definitely seeing improvements across the board by having the guidance system in place.
And two, this is sort of a follow-up to that. For a cloud solution, is it necessary to have an on-premise server as well?
So we do have some localized services that do run on-premise, because a lot of a lot of functionality is delivered through the cloud, but there is a lot of functionality that is delivered locally. And in the event of internet outages, I mean, they're not that often, but they do occur occasionally. We still have some services that run locally that collect the information and store it in the event that there is an outage, and keep certain functions running locally, like signs updating, etc., just in case that does go down. So there is a small server that does go on site, but a lot of all the customer interaction, all of your operator interaction, happens through the cloud interface.
There's also another question here. This is geared more toward the financial side of things. Are parking systems leased or are they outright purchased? And if it is a purchase, how does the maintenance work for that?
So, they are a purchased product. I mean, there's always ways to be flexible around that, but typically, what we've seen, almost 99% of our products are sold and purchased by the owner. What we look at doing is we have a calculation that we use on a maintenance. We provide a year warranty, and then following up on that, we offer different types of maintenance programs based off of the size and the scope of the project. So it varies from project to project.
And a couple of the follow-ups from that are, is there a cost per space for that, or is there an average cost to install these types of systems and the time frame to reach, a full ROI? I mean, I know it's kind of difficult to price out and to pan out there, but is there's something you guys can offer in terms of an answer to those follow-up questions?
Yeah, so that is a difficult question. We can see on the average that there's a range, and really the biggest range is the installation cost. But you can be anywhere from $375 a space up to $500 a space, and it also depends on the number of signs you provide into the project, and then you've also got the other features and functionalities that we talked about, like find your car, some of those surveillance. So there is a cost to those as well, but that's what we see as the kind of like the range. Return on investment really is on a project to project basis. There are some garages and facilities that are truly using it for a customer experience, so that return on investment is immediate. You're appealing to your customer base. If it's on a financial side of it, it all depends on how much more effective is the parking guidance system going to provide you, anywhere from 10 to 15%. So again, it's on a case by case basis. That would have to be calculated out based off the project.
And here's a different kind of ROI question here. It's, can this guidance system help me predict future behaviors of people who park in my facility?
Yeah, I'll go ahead, Scott, because he touched on that and where we're looking at providing a predictive analysis for the future. But Scott, you can touch on that.
Look, that's a piece of development that's underway right now, which is, to date, a lot of the data that's been collected is obviously historic looking, but leveraging that data and overlaying other pieces of information, we are building out a predictive model that enables us to provide insights into what we expect, the occupancy or throughput expected for tomorrow or next week, etc. And there's a few different things that go into that. Obviously, the history of the garage is a huge input, but things like the weather and things like other events that are going on are also key elements to be able to put into the system. So we're building out a feature set that enables you to annotate your historic data to say that, hey, there was a football game on this particular day. There was annotating the weather over time. So be able to say, hey, well, this Saturday we're expecting, this volume of traffic because there is a football game, or there's not a football game, or there is a weather pattern that's coming, or there is exams on, etc. These are all things that we're building into our predictive module that would enable you to have quite a precise level of comfort around what the data, what the volumes could be in the near term.
Sure. A lot of great questions coming in here. Here's one that talked about part of the non-cloud solution that was referenced earlier. Are there custom dashboards and web apps for the non-cloud solution, and do you offer apps to provide API to build any of those apps?
Yeah, so all of the functionality is available via the cloud. So there's no real offline applications that are provided. But there is a full data set that is available through our API set to be able to build your own application. So it's quite common that our data is leveraged and inputted into different mobile apps or websites at different facilities. So, embedding the parking information into your own facility app or your own facility website, embedding that information into whatever the methodology for payment for parking payments is. That information is available through, we've got quite a strong RESTful-based API set that enables both the ability to pull information, but under some circumstances, be able to push information into the system as well.
We're getting to the top of the hour here. We still got time for another question or two here. And one question is, do you have any smaller colleges or universities that utilize their system? And if so, do you have any, case studies or anything that you could share regarding their experience?
The most university campuses, the ones that we provided, are large in terms that they have multiple facilities. But I think the University of Texas, Dallas is a perfect use case that we can share with them. It was actually in your magazine, I think last month, if I'm not mistaken. And, we can provide that because it is for a smaller footprint. So it's for a parking facility of, let's say, 1,700 spaces. Technically they work the same, depending, they're not really based off of size. They're really going to work the same. So we can share that with them if they like.
Okay, great. Sure. So we're nearing the top of the hour here, so I want to be respectful of everybody's time. I want to thank both Jeff and Scott again for their expertise. A lot of great takeaways here. About parking solutions. Jeff and Scott, thanks again very much for taking the time out today to talk with our audience.
Well, thank you. We greatly appreciate it, and we look forward to hopefully presenting more in-depth technology session, one-on-one or another panel like this again, to get more in depth of how, and specifically how our technology can work in under different circumstances.
Yeah, thank you everyone for all of your time, and thanks for joining.
All right, well, webinars like this one today from University Business makes us the leader in editorial coverage of news, trends, and current issues in higher education. You can subscribe for free and stay up to date through our print magazine, our digital edition, e-newsletters, and web seminars like the one you heard here today. So on behalf of University Business, I want to thank you for joining us. And remember that the archive recording of this webinar will be available for you or members of your team to review at the following URL. You will also receive an email with a link to the slides in the archive recording as well. So on behalf of University Business, this is Jason York. Take care, everybody. Have a great day.